Greetings, everybody. This is Eric Andelin, Senior Workflow Advisor with SimActive, and you're joining me for the workshop, Are Larger Format Cameras Better for Mapping? And with me, I have my guest, David Alamillo, Photogrammetry Specialist here at SimActive. David, say hi to everybody.
Hello, everybody. How you doing? And Eric, thank you for having me.
Yes, perfect. So probably everybody knows my background. I grew up in aerial photography and mapping. I started in the back of an airplane, worked my way all the way into photogrammetry and sales and survey and all that good stuff, and now I'm here. But David, why don't you just give everybody a quick refresher as to who you are and what you do at SimActive?
Sure. Thank you, Eric. I'm a photogrammetry specialist here at SimActive. With some of you folks, I've probably interacted either through a support ticket, support email. Always happy to answer questions, and basically in charge of support here in the U.S. for the Americas. Working in tandem with our sales team, working in tandem, of course, with our folks up there in Europe. But always happy to lend a hand, and as we all say, we're all learning here. As new sensors come out, Eric pointed out, very much the obvious, so we're all learning at one point, but really happy to help you guys out on projects that might not be the best. And in projects, of course, that go really, really well. Really happy to see your guys' feedback, right? So again, thank you for having me here, Eric.
Absolutely. So the topics specifically are going to be different camera formats and footprints, benefits of larger format sensors, effects on resolution and quality, and then considerations during processing to ensure success. We have the drone market, which tends to be the majority of beginner users. And then we have on our end in correlated 3D with SimActive, we also have many aerial photography companies that have been around forever. And those companies tend to be much more knowledgeable about the process. And just like the drone operators, they are pushing manufacturers on the technology side to create better sensors. And we see those come along every once in a while. And the example I give is phase one. And phase one has medium format cameras, small format cameras, and they work on something that becomes a large format camera. And it's not to say that phase one was the first to do this. Leica had a medium format camera, probably like late 2000s, and it's still out there. It's still running well, and people like that as well. And you can also talk about some of the even bigger cameras like an Ultracam or a DMC. Those also are multiple cameras put together to create a larger format. They may just be one red sensor, one green, one blue, and a near IR, but essentially in some cases, you're taking multiple cameras and putting together a bigger picture.
That's right.
And that's, David, that's where we're getting to now when we're talking about some of the technology with phase one. But before we do that, just give everybody a quick rundown on what, camera formats would be.
Sure. Like you mentioned, there's just a lot out there in the market. Of course, they have to fit sometimes different budgets, and of course, for different projects, different sensors. As far as the formats, I always get, can we get into brands and probably talk about some brands? For example, we get Ultracams. Very, very popular out in the field, especially in the US. Several cameras out there on the Ultracam side. You get your large TIFF format image that can be natively imported into Correlator. You move into your DMC3s, right? Which you mentioned, like a super great brand as well. As far as formats, we always go with the typical TIFF format. It's basically outputted out of the sensor or post-process. So that's mainly what we see. And then specifically, you mentioned one, which is the popular one right now, phase one. And when we talk about formats and, the different benefits of the sensor, you get into the IAQ format specifically, right? Which is a very, very unique format that, it's a raw data, it's captured. And one of the differences, I guess, from your typical TIFF outputs is you can process it directly into Correlator 3D, right? You can take those IAQ native format and process it right into correlator. So I would say that's one of the biggest advantages of the sensor as well, of how popular it is, and as well how we adapted also to that new trend and new technology that's coming out.
Well, and also, yeah, we talk about the file formats and things like that, but just even on a simpler standpoint, maybe just, how do we break in? It's not how the manufacturers do, but even us, how do we segment what's a small format sensor and what's a large format sensor? So people get an idea. Correlated
Gotcha.
3D, it operates the same way no matter what sensor you have.
We do, and it's an excellent question. We move into the megapixels of the sensor. Really, that's how we break it down into correlator 3D. Really, really easy for someone to understand. Sometimes we're coming in with a UAV sensor, and they have a 61 megapixel camera, which again, UAV sensors have been moving up in the world, and you typically started with your 20, 25, 30 megapixel sensors, and you're up to 61 right now with most UAV sensors and how they're scaling up. And that would be the first tier, a UAV up to 61 megapixels. That's how it's broken down into correlator. You have your next tier, which are your medium format sensors, which you go up to 100 megapixels. That's really the threshold we have as a limit. And then what's above 100? All large format sensors, right? Anything you have over 100 megapixels will fall into that category. And for the folks who open correlator, for the folks who haven't, the first time you're going to open a project, and we'll see it here in the demo, that's the first splash screen you're presented with, right? And then sometimes like, why do I have this one disabled? And then we go into the explanation of, do you have a large medium format? No, nothing into the 100 megapixels, but I will one day. It's always I started with drones, but one day I'm going to hit that 100 megapixel sensor and above. But that's really how we break it down. Simple as that.
You're absolutely right. And to that point, again, the users should understand that our workflow is the same, whether you're operating a drone or whether you're operating a large format camera in an aircraft on a larger scale doing nape photography or something like that. So definitely something that people should be aware of. Now, part of the reason that you have that 60 megapixel limit, 61 megapixel limit, is that those cameras are on drones. And obviously with drones, weight is the factor. So once you start building cameras with more megapixels, you start talking about a bigger physical footprint of that piece of equipment and more weight. So that's one thing to consider. The other thing to consider is when you have 60 megapixel and you're only allowed to fly at 400 feet, you're already pushing the GSD with your camera. So, I mean, we talk about that a little bit. Can you give some just comments on, we all started at 16 megapixel, with a DJI or something like that. Now we're up to 61. What do you process and see this stuff all the time? What do you think? What are some of the benefits of having that 61 megapixel versus a 16? Is there a benefit? Talk a little bit about that from your experience seeing data sets.
Sure, absolutely. And I remember processing my first data set at 16, actually, going down to the Phantoms and thinking it was the best resolution ever. And something I have to say that played into that role as I was moving up was the footprint. That I immediately saw the footprint of the image, size of the image, and then how I scaled up. I was able to cover a little bit more ground. And then I just start zooming into things. I mean, a lot of the stuff we did at the beginning was an inspection. So we had to get, quote unquote, the best inspections pictures ever from a 16 megapixel sensor. The raw imagery will come, will look great, but once we moved into process the image and run, photogrammetry, it looked pretty bad. It would be like, wow, the raw image looks amazing, but the output of the entire map doesn't look that great. As we scaled up in resolution, move up our ways into it, I think the best one I had, actually, I have flown the 61 megapixels on different sensors, but at the time, I think it was up to 20 something, 21, 22 megapixels. I can't remember exactly what it was. It was a game changer. And just going from that DJI drone to a fixed drone with a DSLR camera and way higher resolution imagery. We moved into the inspection side of things. The farmers started zooming in and like, okay, I can see my watermelons on the ground. And that tied, of course, into our GSD, how high we flew, and all the regulations we've gone through. But it's been a learning curve for us, at least on my end, and trying to figure out what sensors could offer as we moved up, and why the increase in price, right? Why would you invest a little more money in getting a 61 megapixel sensor with sticking with your old 25 megapixel sensor? And then when you process the data and you see the differences, it really becomes kind of a no-brainer, right? You want to move up into that world as you start seeing that things get quote unquote easier to process, larger footprint, field of view, and that's when I get into the 61 megapixel limits. When folks say, "What about if I move up into the hundreds?" And then you start seeing, "Will I get better resolution, better field of view?" Of course, everything goes hand in hand. But in my experience, I grew up with that technology and grew up from the bottom up. And I do have to say, I processed a 61 megapixel this morning data set, and it looks great, right? It looks great. The resolution's amazing, and the times to process are really good too, and correlator, of course. So it's a huge advantage.
Well, the one thing I think is that 61 megapixel is again, it'll get you a pretty good looking image at a GSD or a resolution that's really, really fine. More fine than it needs to be when you're talking about doing mapping. So, that's kind of why I see that there's a limit to the megapixels you put in a drone, just because until the altitude requirement changes, you're already at 61 megapixel. You've already got overkill, unless, like you said, you're doing some kind of an inspection, and then it's even better. And then another thing you have to consider is when you're packing those pixels together onto an array, you're potentially creating more noise in the imagery. So you have to be aware of that. And one of the neat things, and you mentioned, at some point we all walked away from the basic camera that was on a DJI to another type of aircraft that was a fixed wing or whatever, and it had a Sony attached to it. And that Sony could capture raw imagery and provide that to you. So when, if perhaps your mapping project over your warehouses had washed out white images, you could go back to the raw and work on it a little bit. So now we're getting into photography, and I know we've got a lot of people that watch the webinars and listen to the webinars and know a lot more about that than I do. But I respect the fact that you have the ability to go to a raw image, or in the case of phase one, directly to their IIQ, and make those kind of adjustments post acquisition. So let's go into what would be considered a medium format camera.
Yeah, medium format camera up to 100 megapixels. I mean, we talked about a little bit of the brands we have out there. It's kind of a mixed segment too, because phase one does have a lot of medium format sensors too that fall into that range. IXM100, for example, that's a pretty nice sensor too. And then we go into adding another component that I've seen with medium and large format sensors, which are calibration reports, right? We get into the whole science of now you have a metric sensor calibrated sensor versus good old plastic sensor on your DJI. So, nothing bad about it, of course. No, for the folks who, I've had DJIs in the past too, and they're great. But once you go move into that segment, something I've seen is you go into the medium format, and you're like, oh, I have this piece of information here that talks about focal length, pixel size, and some other KP1 parameters, and they've had to do something with that sensor before they launched into the market. Of course, they go through, a calibration of the sensor, sometimes done in a lab, very professionally done. And that's where you start getting into that whole world of, you mentioned a little bit more photography and calibration of sensors. And you start seeing really the benefits of having a calibrated sensor, a metric sensor, and the benefits that offers, right? That's a big jump from your typical UAV sensor going into the medium/large format. It kind of, I don't know, but I sometimes put them almost in the same category. I know we divide them by megapixels, but sometimes they kind of bleed in. Just because the workflow is very similar, and probably that's something different that they will see, is that they have that extra calibration options, and they can actually input that into Correlator 3D. That's something that we always talk about.
Yep.
Once they purchase their sensor, here goes everything that comes with your sensor on the medium format side. So I guess for me, that's one note that I have, that it's different, and it gives a huge advantage on the UAV to medium size format imagery.
Yeah, and you're absolutely right. The once you go towards a medium format, that typically means your the drone that you're flying, if you're flying a drone, is more likely either on the multi-rotor side, it's more of an inspection system. And phase one makes something like that too for inspection and zooming in and all that stuff. Different type of camera. But once you get to the medium format world, now you're starting to talk about pod systems, holes in the bottom of the aircraft. So your investment in this whole mapping proposal just became a lot different than
Oh yeah,
the person working in the drone world. It's a different thing. They can both make money doing the
yeah,
things that they do, that their cameras and their platforms are good for. But you're right. Once you go to medium format, then the consideration of, how solid is this camera body? How precise is this lens? Was a calibration ever performed? And don't get me wrong, Correlate 3D will do a calibration for you, whether
yeah,
it didn't come with a calibration. If it's what we call a commercial off-the-shelf camera, which you would see in a DJI or something like that,
yep,
Correlator 3D will map that lens for you. It'll correct all those issues. But when you get into the medium format, you're now collecting a lot bigger areas. And honestly, probably with more liability in what you're doing.
yeah,
And you want to make sure that what you do is defensible, that the equipment you're using is top notch and precise, and that calibration or the information on the lens helps you validate what you're doing and makes the processing a lot easier. So in our case, just go ahead and explain. If we have a calibration file or at least a partial calibration, explain how the process changes for someone in Correlated 3D.
sure. And we'll go over that in a bit, because I think the data set we're going to be covering today gives us that opportunity to read the calibration file and then even make adjustments. So one of the benefits we have is, if you're getting into this world and you said, how do I copy all those values from my calibration report or in PDF format into a usable format in Correlator 3D? All it takes is a simple email to support@SimActive. I'll send you the calibration template and copy paste those values. It's really that simple. There is just a quick email to us saying, hey, how do you get that? It's a .cam file that we can either export out of Correlator, or I can send you guys a template with those values. And they're probably even adding to it, let me put it in our community forum.
Yeah.
That's something that we've been using. I'll make a quick commercial here. Every time I have something that comes up as new, of course, guides that you've created, I always try to flash them in our community forum for everyone to read there. And thank you for the folks who have been logging in. I've been seeing the views. They're up in the thousands. So that means that the content they're looking at, they really like it. So quick comment, I'll put that calibration template in for you guys. So it'll be in the community forum. There'll be a link there for you to download it. And it's a simple copy paste of the values you have, typically your focal length, pixel size, and you have your decentering parameters, of course, your Ks, your Ps, principal points. So we'll actually be dealing with principal points here in a minute.
Yeah.
But that's something that it's extremely easy. Correlator makes it super simple. And that's something that I really like. Something that sounds very technical becomes a very, very simple task of just kind of copy and pasting from a PDF. So yeah, we'll see it live here in a minute.
Yeah, and when you're, for the user, when you're doing your AT and you've got some type of calibration, whether it's, a full calibration, a partial calibration, a calibration report that wasn't even designed to go in to Correlator 3D format, again, we can help you get that in if you have any issues. And it basically gives the software some parameters to start with, and which then makes processing the AT faster. So that's something to keep in mind. Now, the next one and the final one is large format.
Large format. Yeah, I have to say I've had, back to that. I've been talking about large format. Sometimes there are sensors that are very, very expensive. The first time I saw a price tag on a large format sensor, it blew my mind. It was more expensive than my house, and I was like, Jesus Christ! I'm having two of these will buy you a mansion, buddy. And I live in California, of course, so yeah, they'll buy you a huge mansion in Texas. So anyway, it's one of the things that once you're into it, most of these folks who are into the large format sensors and own one or two or three, most of those folks already have their own systems, right? They're flying maybe a Cessna 208. They already have a dedicated aircraft, and they're doing this, like you said, for many, many years, upgrading not only the sensor itself, the large format sensor, but also their aircrafts. So I see aircrafts now that are moving up. And you mentioned something very important with these large format sensors, and that I've discovered that folks who have talked, and I don't own a plane per se, but pilots who do these type of work say, the efficiency of the sensor and the weight of the sensor plays a big role in this, right? How much fuel can you get in the craft, right? And how much survey burn do you actually get from these sensors? And talking about the different brands and varieties, yeah, something I like about these PAS 280 large format sensors is, they give you between 5 to 7 hours survey burn time because of the weight of how they're constructed. So they're making them more lighter and lighter and lighter. That, of course, allows you to fly even more. I'm talking about maybe like a P-68 long range aircraft, and you know more about that world than I do, but you get into those things and you see the acquisition speed is just top notch. And I have to say, and this is something that I'll remind our folks out here, that sensor is worth half a million, $1 million. And when you go into the AT, that's the easiest AT I've ever done in my life. It's just,
Yep.
it's how the French would say, la crème de la crème. So forgive me on my French, but it's amazing. I mean, those ATs, what does I see a large format sensor go like, amazing. I know the AT is going to work,
Well,
and typically that's the case.
yeah, and like you talking about California and the large format sensors. The first large format sensor my family bought was probably 1986. I remember my dad mortgaging the house to buy it.
Oh,
They also flew him out to Heerberg, Switzerland, to see it in production. So
wow.
it's a big deal when you make that investment. Nowadays, people might be buying a large format camera, and you're talking about $1.2 million before you put in the IMU and all the other stuff. So it's a big
Exactly.
investment. It's a big investment. But um, what that large format camera allows someone to do, obviously, is fly much higher, capture a bigger footprint, capture a
Yep.
county, capture, a state,
Yep.
things like that. So they're working in a different world, and you'll see them also now out there doing um, not, collections for potential 3D cities and things like that. So
Oh, yeah.
um, there's a place for all size sensors in
Segments.
our profession. But um, to finish this up before we start, nitpicking things, you mentioned that phase one is combining basically medium formats to create a large format camera. So you can talk a little bit about that.
Sure. Yeah. In this specific one, and I was fortunate enough to process just a data set very recently, and I was doing the math right. There were two 150 megapixel sensors,
Mhm.
and that's how you generate your 284 megapixel sensor. I was impressed, right, when I first saw the technology come out, and this is a couple of years, but of course it takes a little time for adoption. So now I start seeing it become more and more popular. The two 150 megapixels on a single body, and something that's unique about the sensor, and then I've discovered while reading, it's a rotated 90 degrees, right? So the right hand part of that sensor really captures a little bit of the left hand side of the
Yep.
image,
Mhm.
and vice versa, and of course, since there are two sensors, they have overlap in between both. So they have, I don't know, let me see, I think between 5 and 10% overlap. I think it's 5% overlap in between the two sensors. So it's an amazing sensor. It's a great advantage of having something like that. Collecting your data. Of course, it's mounted on an aircraft. If I remember correctly, well, I was doing, actually, we did the demo of this particular data set to a potential customer not last week on Friday, actually. And we talked about, capturing, I think the gentleman said 2 frames per second, 97 forward overlap. I think the maximum GSD he mentioned was what, 1.5 centimeter GSD. And that's where it starts. So I was like, Jesus Christ. I mean, he was capturing 10 centimeter GSD, 150 knots. So he gave me all the technical background of how he collected the imagery, and of course it was just mind blowing, right? What these sensors can do, and and how they're set up and how light they are. That's the main thing that impressed me from what I had read to this sensor in particular, is how light it was compared to other sensors in the market. That's unique. Very, very unique.
And like you said, that all comes down to burn rate, your time in the air, all that stuff. So it makes a big deal. And from our end, we're now looking at a different process where in the past we would do, a single camera, we would map that lens, and then you could do the AT. Now we're taking 2 cameras, putting them together. They both have unique solutions, and they meet in the middle with overlap for us to create an overall large format camera. So
That's right.
We'll talk about that in the demo and how that's done. And again, to remind people, we're not talking about an oblique system here. We're talking about 2 cameras making 1 large footprint.
That's right.
Obliques are a different thing. So
Yep.
and Phase One makes those as well. And then of course they also offer RGB, NIR. There's a couple other things that that come along with that. So
Yep.
I really think that where we need to go now is probably into the demo. And like you said, we've got a data set that you were able to work with. Our other tech, Thomas, had a really nice data set, but that one's massive. That is a massive data set, so we probably won't go down the road with that one. But why don't we go ahead? And I think we've covered the topics. Again, different format sensors, what their sizes are, how are they, what makes them large, medium, small format. And we talked a bit about benefits. The benefit, again, of a large format sensor, even a medium, every time you go up in sensor size, that just means you're probably going to be flying higher, unless you're restricted in the drone world.
That's correct.
And capturing more area. So, and then another thing you just mentioned with this Phase One is the rapid rate that it captures at.
Yeah,
so
that's impressive.
now you could start cranking up that overlap for city modeling or whatever you want to do. And in part because they're IIQ format. That's how they're able to push that stuff through from one exposure to the next as it's going so fast. Is they've come up with their own native format to help do that. So and then again, again, we're talking about megapixels and what their resolution is on the GSD on the ground is based on how fly you high or how high you fly and your the focal length and all that stuff. So it gets into bigger deals. But since we want to talk about this medium to large format system that Phase One just came out with and how we can process that in correlated 3D. Why don't we go ahead and head in that direction? So go ahead and go into the demo.
Well, once you open Correlator 3D, as I mentioned, if you go up to the first module, left-hand side corner, you'll see exactly what we're talking about, the different formats, the different types of licenses that you can purchase for Correlator. And it's a simple update. So folks that I've seen move up into the medium large format, or I have to say, folks that are also asked to process data, right? Some folks out there are processing data from multiple clients, and they'll come up with a project that is flown with a large medium sensor, and they'll say, yeah, I'll need this for the summer as I'm processing data for this particular client. Don't feel shy to talk to your sales rep and upgrade your current license to a medium large format. So that's a pretty simple task and easy to do. And that's exactly what we're going to be clicking today. So let's go medium large format. And here's where the fun begins. So I mentioned earlier that depending on the sensor, you'll have different ways you can configure your camera. in this case, and let's go ahead and browse really quick for that sample, for that input. And just to show you guys, the one we're going to be processing today is the phase 1 PAS 280. And here's a calibration certificate. Just wanted to show you a little bit of how the sensor looks, and then a little bit of what we were talking about, right? The left sensor, right sensor, and the overlap you have in between both. So that means there are basically 2 sensors in there. So we're going to treat it as 2 sensors coming into Correlator 3D. Therefore, your configuration is going to go as such. You're going to go 2 cameras, but they're not 2 different groups. They're actually labeled under one group, right? Because we have only one body. So we're going to put it within the same group. And something I like to do to the camera ID is begin adding just a letter to differentiate my camera right and my camera left.
Great.
In some cases, you'll see that you have all these images, your IAQ images from this particular sensor, in one single folder. So that's the only differentiation that we'll add. We'll hit next. Again, remember, they're only part of one group because they're mounted on the same body of the camera. So we're going to go next. And then we're going to go add our files. And as I mentioned before, let's go back here to our sample imagery. And we're going to go to the IAQs. We have the benefit here actually of having the TIFFs. And the TIFFs actually are processed through IX Capture. So for the TIFFs, we already have them merged. I'll show this really quick, Eric. We have, like I mentioned before, all the TIFFs already merged left and right. And of course, there are benefits to this. You know, if you go through IX Capture, do apply some distortion corrections as well. So if you guys want to go with the TIFFs, you can. In this case, we're saving time and going through the IAQs, and we're going to go into our folder with our IAQs. And as I mentioned, you have them within the same folder, so we're only going to select our rates. So they're labeled RGB_16R, and they have, you know, the event name, which is 14, plus the R to let us know they're basically all our right images. So we're going to select here all our R images. You can even, you know, be even more productive than I am and actually put them in a separate folder, you know, and then have them just import all of them as a separate folder, and all the images are already going to be your R. In this case, we're going to open them, and by default, we're going to read all the EXIF information of the image: long, lat, altitude, roll, pitch, and yaw. We can go straight up with the EXIF information of the image, begin processing. As a second option, and this is a popular topic actually, Eric, where we see folks running this through Planix, through Postback, and they have already an EO file that it's produced by Postback. So in this case, the file is going to look something like this. And a couple of folks have asked me, you know, after I ran it through Postpack, you know, I ran it based on the TIFFs. So I really truncated the entire naming convention of my IAQs. How can I fix it? And I told, don't worry about it. It applies. The only thing we'll need to do is important thing. We have the event names, 14 through 19. And if you remember, your IAQs are labeled that same way. So the only thing we'll need to do is copy paste these values into a spreadsheet, and then basically just assign them, you know, either the naming convention, left or R, and we can even do it through a simple script. You know, our colleague Thomas is so well versed in Python that he loves to solve everything with a script. He'll be like, you know, let's run it through a script, David, and he'll do it on its own. So there's so many ways we could do it. We can even do the old-fashioned way, and you know, I find and replace, simple task in Excel, and just simply replace all the 14s with the naming convention of your IAQs. I have to say, obviously, because of all the header information here on your Planix EOS, we can't take it natively, but it's an easy way to export into a spreadsheet, and then you'll get something like this, which here you can see I basically keep all the information. The only thing I've modified with the replacing naming convention is the ID. So you have your RGB underscore 1_6_14 event, and R, which is the naming of your IAQs, and that's the only thing we'll need to do as a second step. So again, this is in the case you want to use your Planix EOS. Like I mentioned, you have the 2 options. Let me close this out. And if you wanted to go with the EXIF of the raw IAQs, you can do that. If you want to import it, we will go to the TXT file, 3 dots, and then we'll browse, obviously, for our EO file that we just created. So we'll go to input, and here I have one that's called update IAQ, open. And we can go through the simple addings here. We can go changing our easting, northing, or position system, either omega phi kappa. And then if we don't have an extension for them, we can add an extension, either IIQs or TIFF. In this case, it has an extension, so we'll go disable the first row. Very important, guys. Sometimes I get questions about this one. It's like, hey, it's not working. And it's just basically disabling the first row, which is denoting, what each column represents. Going down here, selecting image. We have our event, time, and go to our different positions, easting, northing, elevation, and the same applies for our omega phi kappa. I won't bore you with doing this, but that's one important part of it. In this case, we can go with the EXIF of the data, so we don't have to redo each one. So we're going to go again into imagery, IIQ, and we're going to select all our R's. And then we'll do the same thing with the left ones. And again, we can probably speed up things a little bit. So we're going to go, and the next thing is working within our projection. Of course, you can work into all your common systems, state plane coordinate system. We're going to stay here in UTM, hit OK. We're importing just 5 images here. So we have the dimension of the image, the projection we're going to use, hit next. And here's an important part. So as I mentioned before, some folks have lost their calibration reports. This is not uncommon, where you'll see the folks say like, what is that? When did I ever get a calibration report? And it's also, normal that some of these sensors, they've been bought, through a friend, or, basically a couple of years old, so you don't have the calibration report anymore. And not even that matters, because some folks even work with the lenses and, take off the lens, so that calibration report's not even valid anymore. So as you clearly mentioned, Eric, having the calibration done within Correlator is also a huge benefit. So if you folks want to go with just your focal length, that's the only information we have, which is your focal length and your pixel size. Don't worry about it. We'll basically do the calibration of the sensor within Correlator, so there's no penalty of going with this. Now, what about if you have your calibration for this specific sensor? We're going to go here and open up our calibration report, and we're probably going to go to the bottom, which is where you have it. Let's go ahead and scroll all the way to the bottom. And we'll see our calibration, right? We have our focal length and our pixel size. So here's something important to note. And with this particular sensor, like I mentioned before, you can go with only your focal length and pixel size. We'll do the calibration of the sensor, and I'll show you how to do it actually in Correlator. There's a 2-step process. Or you can simply copy the signs of your X coordinates. Specifically, you can copy your focal length or the principal points, and then swap the sign. So minus to plus, plus to minus, and that's all the magic that happens. So here we have a value of 17, that would go minus. The other one, your principal point XP there has a value of minus 18, so it'll go plus 18. And that's really the only thing you'll need to do. And as I mentioned before, I can help you with this. If you have any questions, email support@SimActive, and I'll help you find the correct principal point. If you say, like, what did he say, minus, plus? Don't worry about it. And also, if you don't want to go through this, the easiest option, as I mentioned, is you can copy your focal length and, of course, your pixel size, so go with that. And then we'll do the calibration of the sensor within the software. So I'll show you the second method, which is extremely simple. And for that, let's actually do that, Eric. Let's go only with our focal length and pixel size, and let's actually do that calibration within the software. Again, now you can see for the image selection, we get camera L. We add our files, same way we did with the previous one. So we'll start off here with the first one, L. And where's my last L image? Again, I'm just pressing Control on my keyboard and selecting the image, hit open. And there we go with all L images. So let's go ahead and speed up this a little bit. I think I have 6 for this. Maybe I imported one more. And again, same values. Focal length and pixel size remain the same. Next. And yes, we'll actually change our project folder location so we can save it into our project folder. And now, speed up a little bit the process. We're going to go ahead and open up a project that we have here who has everything in there. So let's go ahead and open up this project. We have all our images laid out right there. It's a single flight line, again, just for demo purposes. But you can see actually how much it covers, right? Going into the benefits of large medium format versus drones and the altitude of what you're flying. Something to note, it's very important, you have on your images, your camera left, your camera right. So you can basically turn those images on or off, and you can actually see that image here displayed. That's the R versus the left. So we've turned this one off. There you can see the left side of image. So IAQ left 18. So again, you can simply disable them here to see which one you want to display. But importantly, we're going to go directly into the AT. We're going to go and perform an error triangulation. And of course, I've finished it here. But the first step it's going to ask you to do is your type point extraction. That's, by default, it's going to ask you, would you like to do your type point extraction? We're going to say absolutely. Let's do standard. And you're going to see your images added with their own type point extraction here and your links that you see here. Let's open up one just for the sake of it. All the links included there from the type point extraction. This is standard, by the way, so pretty good job there. And here's where the magic comes, Eric. If you remember, we only did focal length and pixel size. So the first step we're going to do is we're going to calibrate our sensor. And how are we going to do that? We're going to do a first bundle adjustment. So let's go to our bundle adjustment tool. We're going to go to the EO adjustment, set it to none. We're not going to deal with the images and EOs right now. We're only going to do an unconstrained sensor calibration and process. So that's the very first step. And again, this is going to run some magic. And then we're going to run our second step, which is typically our second bundle adjustment will adjust the EO. So we think you do a full AT constrained our XYZ, omega phi kappa. That's again another option. If you want to go with an unconstrained sensor calibration, you can too. Of course, let the software do the magic, move the images as much as you want. And we'll keep the sensor calibration under unconstrained as well. Ground reference, we don't have any GCPs. That's where they're grayed out. We'll process it. And I want to show you something really quick after we run it. So it's a two-step process. The first one, only do the sensor. The second one, do your EO and your sensor. And let's look at the report. You'll see you'll get excellent results, average projection error, standard deviation, of course, an average number of type points per image. Very important. The next one we're going to look at is what we used. I used the unconstrained sensor calibration, unconstrained EO adjustment. But more importantly, we're going to see what it did with the calibration. Here's the average movement, maximum movement of the image adjustment. And like I mentioned before, what's really important for me is what we did with the calibration, right? You can see here the X principal point. That's the one we were dealing with. We have adjusted 16 millimeters, for the X principal point and minus 19 here for the other. So L left, camera R right. And we could have done this manually when we were doing, again, the import of the image and setting the camera calibration and changing the minus for positive. Or we can do this two-step process, which for me, it's super simple, easy to do, and let the software do the calibration and adjustments of your X principal point, and off you go. I wonder if this clear, Eric, would you have any other comments here, questions perhaps for the folks that are in the audience?
No, I think you explained it well. And again, we have a community forum, we have David available and Thomas available when people maybe run into issues with calibrations. Just what I would say to people is don't get hung up on it. If you don't have the calibration report, you don't have a full calibration report, not to worry. Correlator 3D will do that calibration for you. So I'm good with everything you've talked about there.
Nice, buddy. Yeah, I want to be as clear as possible. And again, folks, if you have any questions, feel free to email us. We'll always be available there to answer your questions. But this is the setup for this specific sensor. And, based on the reference frame, that's why we have to switch the sign. So software will do it for you, which is amazing. Now,
yeah,
go ahead.
So I was going to say from there, really, everything else is the same, correct? The workflow is exactly the same. The only thing I'd like to comment about is I mentioned that my dad bought his first camera in 1984 in California. And by the way, the house he mortgaged is almost in that photo.
No way.
Yeah, it's Irvine, California.
Yes, sir. That's Irvine, California. So let's go ahead and actually open up this into a full project and look at the mosaic probably. And how far did we miss it? Is it
That's
maybe
pretty
north or
close.
south. Pretty
Yeah,
close.
no, yeah, you're pretty close. You're within a mile.
Oh man, that's
Well,
nice.
what I'd like to comment about this, and you're pulling up the mosaic, and it's great. And for people, just some background stuff. Sometimes when David or Thomas are working on something, they'll have me do a final run through just to make sure everything's okay. And I can tell you, I was very impressed with the seam line editing, automation within Correlator 3D, working with this camera. And you could turn on the seam lines if you want, but what people don't realize is these big footprint images, there's a lot less seam lines. And because there's a lot less seam lines, it goes by much faster. So something to be aware of.
Absolutely, and something that I also point out is, with these type of sensors is not only the seam lines, right, but the options you have with the IIQs to work either a 16-bit imagery or
Yeah.
8-bit. That's something that a lot of folks tell me, hey, you know what? When I ran through IX Capture, I get 8-bit imagery. How can I go back to 16? And I always end up mentioning, you have your raw IQs? Yes, sir. Dump them in Correlator. Oh, I didn't know you could do that. Absolutely. So as soon as they're processing that, when they get to the ortho rectification stage, and this is where you change that, before you ortho rectify, at the bottom, you have an option to change either 16-bit or 8-bit.
Yep.
And something that I have to mention on this part of the process is we do stretch the histogram. That's something a lot of folks mention. It's like, the histogram looks stretched. Absolutely, for display purposes only. So we're going to stretch the histogram, but again, on disk that remains the same. No issues there. And I'll point something out really quick too. Before you ortho rectify, I usually create an additional folder, right? So I'll have a folder that it's my 16-bit ortho rectification. I'll click on the plus sign, add another folder that's specifically 8-bit, and then I can switch and toggle between my two folders if I want to export an 8-bit mosaic or 16-bit. So that's another thing. And to that option, if you remember the TIFFs, I would like to show that workflow as well. Some folks say, what about if I ran it through IX Capture? Can I still process those raw TIFFs in here and not do the IIQ workflow? The answer is yes, absolutely. You can actually do that. So let me open up the second project I have. This is with the IIQs. I also have the same project done with the RGB. And of course, these are 8 bits, so that's why you see the difference a little bit in color here. But just to point that out, these are, again, very seamless workflow. Rather than having now the two cameras, you only have one because they've been ran through IX Capture and exported as TIFF, of course, we mentioned. But really the same workflow. So you get the best of both worlds, either you want to do one workflow or the other.
Yeah, very interesting. And again, as more and more users come online with this specific camera setup, our team here, David, Thomas, everybody here is ready to support you when you move in that direction.
Yeah, no, absolutely. And finally, to your point, how easy the seam line editing workflow is. I mean, it's I'm being picky here with the palm trees here, of course, on the center of the image. So I'm moving a little bit the palm trees to just fix a little bit where we are. But other than that, simple edits, clean corners, but it's amazing, right? The quality you get from these sensors and the little work you have to do as a post process, in the office trying to clean up. I'll make a quick commercial here. We are coming up with an update for the Mosaic Seamline Editor.
Don't give away too much. Don't give away too much.
I won't, I promise. I'm just gonna say it's amazing. So
I have seen it as well. People are going to be floored.
guys, hang in there with us. You're gonna see some magic happen there, and it's really, really cool. So to that point, this is a really nice project, really nice data, and if you guys have any questions, I'll be more than happy to help you guys out with that.
Well, very good, David. I appreciate you for taking people through the demo and showing them, what the value of this camera is, this phase 1 camera is, and how we go about the processing. For those that followed along and might have had a question, we will answer your questions as soon as possible. And also remember that this webinar, as well as our previous webinars, our podcasts, are all available on our website, www.simactive.com, under the Learning tab. David, thanks again for joining me.
Thank you, sir.